Okay, YouTube, in this video we're going to be exploring arithmetic sums, or finite arithmetic sums. So that is to say, let's say, for instance, we had some arithmetic sequence, something like maybe like 4, 1, go down by another 3, be a -2, -5, -8. I don't know why I chose to go down by 3s, but something like this, we know the first term would be 4, and the common difference here is -3. Something arithmetic like this is so predictable that if we were to start to explore what would we get if we were to add up, say, the first however many terms of this sequence right here, and we would say that maybe the sum of the first n terms. That would be something I would be interested in doing in certain instances. Well, they're so well behaved that we can define a rule. We're basically going to explore this rule really quickly here before we say this is what it is, but let's go ahead and take a look at why we can derive such a rule and then use it to easily find some finite arithmetic sums of the first however many terms of an arithmetic sequence. So we say that the sum of the first n terms of an arithmetic sequence denoted by s subscript n. And so one thing we want to write here is this. This is the nth partial sum. I'm not going to write that again. It says it right here. The nth partial sum, but it's also the sum of the first n terms of the sequence. And so essentially what we're saying when we write Sn is, would you please and thank you go, starting at the first term, add up all the terms from it to the nth term wherever I tell you to stop. So if I were to write, for instance here, S5, we truly would mean A1 plus A2 plus A3 plus A4 plus A5. That would be an example of what we're talking about here. So we say, let this be the sum of the first n terms of the arithmetic sequence. Well, because D is the common difference between the terms, then we say that the sum of the first n terms, or S sub n, can be written forward and backwards as follows. And so essentially what you're seeing here is this. We say S sub n is our first term plus D plus our first term plus 2D plus all the way out to the nth term. And so we're doing this. And then what we see here is Sn, and what I want you to see is they just turn this all around. So they say this is An, this is the last term starting at the beginning, and our first term A1, I'm going to put it at the end. And instead of, our next term here, instead of A1 and then A1 plus D, we're going to have An and An minus D, and then we're just going to go in exactly the opposite order. And so what you're going to see is that you're going to get your D's to cancel out, and we keep getting this A1 plus An. A1 plus An, A1 plus An. And we just keep doing this. And as a matter of fact, if you were to add S sub n plus S sub n, you would have 2 times the sum that it is that we're looking for here. And what it is that we're looking for is S sub n. And so if we were to divide now both sides of this by 2, basically we would come up with this formula here that says, well, all we're really going to do is this. We're going to take the number of terms that we have here, and that would just be n. We have n terms all the way across the board. And so we're going to say we got A1 plus An every single time, n times. So we're going to take n times all of this. But see, here's the thing. That was twice as much as what we need. So we're going to divide this all by 2. And what you see is we arrive at what we get here. And it's a little bit different form of the same thing I've just written. But it basically says the sum, or S sub n, of the first n terms of an arithmetic sequence is given by this. And so what it indicates is what we need to know are these 3 things. We need needs. Okay, these are the things we need to know here. So it seems we need to know our A1, or our first term. And so if you're not used to this yet, get used to it. We always need to know our first term. We also need to know An. I'm just going to write the last term in the sum. And then we say n is the number of terms, okay, being added together. If that's the first n terms, then that's the number of terms. So that being said, what we're going to do is we're always, if we're going to find the sum of just a set number of first number of terms of an arithmetic thing, we're going to add up the first and last term in that set of numbers we're adding, and then take it times the total number of terms divided by 2. And so let's take a look at an example, or some examples of where this would come into play. And so I'm basically going to rewrite here our formula for this. But our formula says if you want to go add up the first n terms, we're going to take the number of terms, divide it in half, and we're going to multiply that by what we get when we add up the first and the last term. So for this one here, it says find the sum of the first 15 terms of the arithmetic sequence given by this. Well, I'm going to write down a few things. First of all, I'm going to write down that A1 is 3. And because it's arithmetic, I'm also going to write down the common difference here is 3. Now, one rule to always have for yourself, no pun intended, is to go write the rule for this thing. So our rule here would be our first term, which in this case is just 3, plus now common difference 3 times n minus 1. And simplifying all of this, we get a rule, which the rule is this. We get an equals 3 plus 3n minus 3, so we get an is 3n. Okay, so I wrote down the first term. We need this. I wrote down the rule for the nth term, okay, and I needed d to tell me that. But in terms of finding the sum, let's go ahead and write down our sum. We want the sum of the first 15 terms. So let's go ahead and indicate what we need here. We need to know n, and in this case, we say n, in this case, is 15. And so we'd say 15 over 2 is what we get here. And I'm actually going to put parentheses around just the 15 here because I plugged it in for n. So now we're going to take this times our first term value plus our last term value. And in this case, I'm going to say this is our first term. And just to be clear on this, in this case, our last term would be the 15th term in this sum. So we're going to need to know A1 and A15. Now the good news is we know A1 instantly because it's just there, it's 3. Now A15, now here's where the rule comes into play. We needed the rule, or we should always go find a rule because you never know when you need to know a given term in a sequence. And so we could say that the 15th term in this sequence would be 45. And so we're going to go ahead and put that up here also. So evaluating this, essentially what we get here is 15 halves. So 15 halves times 48, I suppose, here. And so saying that this would be over 1 here, we could cancel out, cross-cancel our 1 and our 48. They share a common factor of 2. And so we'd say 15 times 24, and so 360 here. And so 360, what is this? Well, we want to be clear on this. This is S15. And so essentially, this is the sum of the first 15 terms of the sequence given by the rule we had there, or we got. And so that's what we mean by S15. We also refer to this as the 15th partial sum. And that's just because we're adding a part of the sequence up. So now looking at checkpoint 5 here, it says find the following sum. Here's what I can tell you. It's written a little bit differently. Underneath what we're going to write is S30. And the reason why is because remember with sums, this says start at this term, and this just basically means start at the first term and go out to the 30th term. So really we're finding the sum of the first 30th term to the 30th partial sum, and we're already given the rule, which is like way awesome because here are the 3 things we need to know. N, we need to know our first term. We need to know, in this case, our 30th term. So if n is 30, and we need to know our 30th term and our first term, let's go ahead and find those. We would say our first term would be 6 times 1 minus 11, or in other words, 6 minus 11 is negative 5. And then A30 would be 6 times 30 minus 11, or 180 minus 11, or 169. And so we get this here, and so our sum, our 30th partial sum, would be our n, which is 30 over 2, times now A1, which is negative 5, and then A30, which we had was 169. And so let's add these up in here first. I suppose we would get 15. This simplifies to 15 here. And then taking 5 out, this is 164. And so I don't know this one off the top of my head. 164. So turn this on. 164 times 15. So we get 2460. So 2460 would be the sum of the first 30 terms of the sequence defined by this rule. So for the last example, what we're going to do is look at kind of a modeling situation. So it says, okay, try this on for size. Your grandmother has assets of 500 grand, half a mil. One option that she's considering involves an adult residential community for a 6-year period beginning in 2014. And so this model here describes the yearly adult residential community cost n years after 2013. And so one thing we want to be clear on is that our first year here, or not our first year, but the 0th year is 2013. So it says, does your grandmother have enough to pay for the facility? So one way to look at this is we could say, well, then how about this? How about A1? A1 would be 1,800 times 1 plus 64,130. And so just like with my calculator here, we'd say 64130 plus 1,800. And so 65930, basically 65930. If we were to look at A2, this would be plus another 1,800, so I'm going to add another 1,800 on this. We don't have to keep this up for very long, don't worry. So I'm going to say plus, clear. Let's try plus. There we go, answer plus 1,800. Basically what I want you to see is 67730. If I were to say, if she was doing this over like say a 2-year period, would she have enough money? What you could see is I would want the sum of these right here. But because she's doing it over a 6-year period, what we're going to do is we're going to go find the cost of the residential facility over the first 6 years and add them up. But because this is arithmetic, we can recognize here that this 1800 is like our slope, so our D is 1800. And we could find the first term, and we have that, right there. Basically, what we're saying is, since it's arithmetic and we want the sum of the first 6 years, we could find a finite arithmetic sum. And so what we're going to need here are these things. We need n, we need a1, and a6. So we'd say a1, a6, and this is going to be our n. So n is 6. We need a1. a1 is 65930. I'm going to squeeze this in here, 65930. Because we have the rule here already, we're going to go out and find the 6th year. And so we would say that this would be 1800 times, not plus, times 6 plus 64130. And so we would get 74930. So 74930. So this is calculator worthy. I will say that this is a 3 out in front right here. So 3, when I type this in, I'm just going to hit 3 here. 3 times in parentheses, and I suppose we could say 67730 plus now 74930 end parenthesis, and what we end up with is 427980. So 427980, and this was a representation of money. So the question here is she going to have enough to pay for this over a 6-year period beginning in 2014? Well, according to this model, she's got $500,000. She should be able to do it. Cheers.